Hey, this is Passy from Passy's World of ICT, the guy with the white hat, and today we're here with another totally awesome Python programming lessons where we're going to make some repeating patterns and some spirals and things that look really great. So let's get into it and get started. Alright, so today's one is repeating patterns. So I'm going to use the for next loop again to do repeats, but we're going to learn another type of new loop, which is called the while loop. And these are very important just in normal Python programming, not just in drawing pictures, okay? But we're going to draw pictures to learn them. So we can use those sorts of loops here to have this repeating squares program here on the left. So you can see the turtle draws one square, then he does a bigger one and a bigger one and a bigger one till we get this kind of tunnel of squares, which is kind of really nice. And this one here is kind of twisted tube of circles. So we're going to do that using repeating loops as well. So we just have to kind of do one circle and then make more and more of them and make them get bigger. And this one here isn't actually squares. They're kind of squares that have 91 degrees in them. And that gives you this really nice kind of spiral effect, all right? So we're going to sort of go from doing a tunnel of squares to a tube of circles. And finally, we'll end up doing our super duper here line of spirals with bent squares. Okay, so we're going to start small and then make them progressively bigger and bigger, and that's the idea of this with the repeating patterns. Okay, now remember our full programming course is on the Passy's World of ICT website under the Python tab. And we'll show you what we mean there. Okay, so what we're talking about is, this is the Passy's World of ICT website. If you click on the Python tab here, it'll bring up the Python page, and welcome to Python programming. Now here it has the lessons. Now we are up to this one, turtle, right, repeating patterns. And it says coming soon next. We haven't actually made the web page and the downloads yet. We'll be doing that after the video. But that one's there. Now you need to have done these other three. You need to have done the Hello World program, just so you know a bit about basic Python and how to get the IDE going and how to run your programs and all that sort of thing. You need to have done drawing shapes, because if you don't know how to draw a square or a circle, you won't be able to make a kind of tube or spiral of them at all. So you need to know the basic shapes. We need to know the pen up and pen down, which we learned in Turtle, multiple shapes here. So to draw sort of one thing and then another thing afterwards, we need to do pen up and pen down. And for positioning, repositioning the turtle. So you need to have done that. So you need to have done 1, 2, 3 lessons before this one. And this is the way the lessons go. They go in order and they build on each other. So you must have done the ones before the one we're doing now. So if you haven't done any of these, sorry, you'll need to go back and do them. And then you can get on to this repeating patterns lesson. Okay, so the learning objectives for this lesson are, you need to have done, like we said, those previous lessons about shapes and repeating shapes. And it's vitally important you've done them, because you won't really be able to understand a lot of the material in this lesson unless you have that background learning from the other lessons. Now, in this lesson, we're also going to do functions. We're going to do Python functions, which is a new thing, kind of like a subroutine, but with extra features added on. We're going to do more repeating loops. We're doing those all of the time, and they're an essential programming structure. Hopefully you're getting an idea of the for next loop from having done lessons so far. And this lesson will introduce the while loop as well, a new kind of loop. So it's going to be fun making all these repeating drawings, but it's very important that you don't just kind of, oh yeah, I'll just type the code in like a little monkey and run it. And oh, I got a nice little repeating pattern. That looks really nice. You need to kind of go through and understand what you're doing as you do it and kind of retain that information for future lessons. Okay, so it's very important. I'd suggest getting the downloads for this project, all right? So you've got the step-by-step instructions. And in this particular one too, there's going to be 7 challenge tasks in this lesson. And we're going to give you solutions for those that can be downloaded as well. If you're a teacher, you might want to keep those solutions and not give them to the students straight away, but you can give them the step-by-step instructions part of the download, all right? So the downloads are really important to help do all this stuff. All right, now the idea is we're going to make these progressively bigger kind of shapes, and that forms the pattern, the repeating pattern. And we're going to do a thing called a function. So what we've got here is we're doing this for I in range 4 and turning left 90. So that should be pretty familiar by now that that's going to draw a square. But instead of saying turtle forward 60 or turtle forward 80 or turtle forward 100, what we've done is we've just got turtle forward and use a side length value, okay? And the side length value is going to get passed in as part of the procedure. So when we do this, it's called a function. We'll explain this more later in the lesson, but then you can just say draw square size 60, draw square 80, draw square 100, and it'll go off and draw the square with that side length you've got in brackets here. And that's how we got a 60, 80, 100, 120, 140, 160 kind of square happening here, and got that sort of a squares tunnel starting. All right, so that's the sort of thing we're going to be learning in this lesson, some things about functions, which is something new we haven't done before. Okay, now repeating patterns, we gradually build up our skills, and the final one we make is this tilting squares. Well, they're not actually squares, they're 91 degrees instead of 90, which ends up making this really nice spiral. But in this, we're going to use a counter variable and use a while loop. See how we've got while repeats count is less than 300? All right, so I'll be explaining that. That's the while loop. That's an alternative for using a for next loop. And when you look at programs and you're doing programming, you'll see examples of both of these. So it's important that you understand both ways of doing it. A bit like playing tennis, you know, you have to understand the forehand and the backhand, even though both of them hit the ball and get it over the net. They're kind of similar, but they're different. And for next and while are kind of similar, but they're different. A bit like your forehand in tennis and your backhand in tennis. So everything's explained in those PDF step-by-step instructions. There's 7 challenge tasks. This is just one of them. Okay, so they're in the detailed download, each of the challenge tasks, and we'll have a look at them during this lesson. This is challenge task number 6, where you make this rounded hexagons flower. Okay, so that's just a preview of one of the challenge tasks. We'll explain about that more. But let's get across to the PDF step-by-step instructions and actually start doing the learning for this lesson. And we'll start with that repeated squares kind of tunnel that we were making as the first one. And then we'll move our way up to doing spirals, and we're doing like hexagon flowers and really advanced stuff. Oh, and I just need to say, if you don't know it already, I'm a bit of a slow talker and go a bit slow sometimes. So it's best to go to the tools cog on the video player and click on that cog-shaped wheel, and then you can adjust the play speed and make the play speed like 1.5 or 1.75, just so the whole video is going a bit faster, and that'll probably work a lot better for you. Okay, so Turtle, Python programming, Turtle repeating patterns. Now, we're in the PDF here, so this is the PDF that you get with the downloads, but we found a problem last time in Camtasia when we were making a video that and you can see the PDF is, you know, good clarity and good quality here, so that's not an issue. But the issue was in Camtasia, moving the mouse around, it didn't seem to show up on the video when we rendered the video out and we're editing the video. So we're just going to try this out using the original Word document that PDF came from. So you'll be getting the PDF in the downloads, but don't worry, the text and pictures in it and everything are all crystal clear. It's good quality. It's just that we're going to try using the Word document here to see if we can get some sort of cursor effects actually happening as we're doing the video. All right, so program 1 is this bigger and bigger squares program. So you started off as usual. We've got some comments there just saying what the name of the program is. You need to have the import turtle, of course, because we're doing some turtle graphics. We're just making a 500 by 500 square screen to fit everything on. We want to see the turtle while it's drawing. We'll hide it right at the end. We're going to set the turtle speed slow so we can see what it's doing as we're developing this. The color there, that blue, you get by using cyan, and the background color is black. So you set all that up as usual, and then we're going to move the turtle down to the bottom left-hand corner with the pen up, so it's not drawing while it moves. So pull your pen up off the page, move the turtle on that, then you can put your pen down, and we're just going to draw one square here down in the corner. All right, so what this does is it just draws a square down here in the corner of our screen. Okay, so get that coded in, get it running. So use the downloads, get those so you can see the instructions. So you need to like bring your pen up, move it around, do all that, and get this first square. Okay, now that we've got that first square, we can modify the code so that it draws two more bigger squares, okay? So what we do is we have it for I in range 4, which is how we do a square, but this time we're moving forward 120 to make it a slightly bigger square. Again, we're turning left 90 as we do when we make squares. So that'll make one bigger square. And if we do another for I in range, this time going forward 140, that'll make an even bigger square. So we're just adding that code underneath where we did the first square. So we'll now have code to draw 3 different squares. And when you run your program, what you should see is that it does the first one 100, then it does 120, then it does the 140 square, and it finishes up here. All right, now we want to make it draw lots and lots of squares to kind of get that 3D tunnel effect. So what we're going to do is we're going to set up a def subroutine to draw the square, but we're actually going to pass the subroutine a side length which it can use. All right, so we're going to set up this kind of def subroutine that can draw squares, but it can cope with drawing different size squares depending on what side length we pass into it to do. So think of like a drive-through car wash. You can take a little tiny car through there, like a Toyota Echo or some real fuel efficient tiny baby car, and it'll adjust and wash that. Or you can drive through a medium car and it washes that okay. Or you can take a really big SUV or a 4-wheel drive off-road vehicle or a giant pickup truck or a ute, and it can do that as well. So it applies the same washing procedure each time, but you can pass in different sizes into that car wash, all right? Or think of a robot that's cooking some eggs, and you can pass it 1 egg to cook, or you could pass the robot 2 eggs to put on the griddle and cook, or pass it 3 eggs. So you can pass it bigger and bigger amounts, and it can cope with it doing the same process each time. So how we write one of these functions where we can pass values to it is, it's the same as usual. We just have our def draw square subroutine, but where the brackets were here and they had nothing in them, we're just going to put a thing called side length in there, spelt just like this, all right? And then we just say for I in range 4, turtle forward. Now the amount we want it to move it forward is the size of the side length, which we're going to be passing to it, all right? So down in here, you can just keep passing your bigger and bigger side lengths into this function, okay? It's a def, but we're putting something in the bracket, so it's no longer called a def subroutine. Now it's called a function. So we can say draw square 60. So what happens there is, because 60 was in brackets, it's going to say, okay, def draw square, and our side length they've passed us is 60. So we need to make a square that has going forward by 60. On the next one, when you say draw square 80, the side length passed in will be 80. So when it gets down into this part of the code just here, it's going to know to put an 80 in for the side length. So we're getting a 60 here, then we're getting an 80, then we're getting the third one's a 100, so it passes in 100. Now good old little turtle goes off and does 100. Then we say, hey, turtle, draw another square, but this time we want you to use a side length of 120. So when it gets down to doing the for I in range 4, it's going to go across to 120 and make a bigger one, all right? So that's going to give us this kind of building the tunnel of squares happening there, and we've done all that by using a function in Python, all right? Now this is brand new. Chances are you might not be understanding it. Suddenly our def subroutine looks super complicated because we've got this thing called side length in it. But we just have to use like kind of like an algebra variable name, like using x or y in here. And here we're telling it what xy value, what the x value is we're substituting in. So, you know, if you have an algebra equation 4x, here we're saying, okay, work it out when x equals 60. Work out the answer when x equals 80. It's the same idea as algebra substitution. That's your algebra variable side length. And here we're telling it to do substitution sums and substitute in these values for that variable called side length. Okay, so if you want to think about it like algebra substitution, that might help you understand it a bit better as well. All right, so get that code typed in, change your program so it all looks like this, and run it, and make sure it's doing this kind of a set of squares here that are getting bigger and bigger each time. Okay, and as you imagined, enough is never enough because we want to be programmers who are totally awesome Python programmers. So we want to make this super professional. And so what we're going to do is we're going to kind of make it work out how bigger to make the side length each time itself. We're going to teach the turtle to be smart, but we're going to use increasing by 10. Just to get a few more squares drawn in our pattern so the 3D effect looks better. So here we're increasing by 20 each time. We're doing side length was 60, then we did side length plus another 20 makes 80, side length plus another 20 would make 100, that side length then if you added 20 on would make 120. So we're going up by plus 20 each time, but we're actually going to go up by plus 10 each time in this code just so we can get twice as many squares happening and it's going to look better. All right, so the pseudocode or the plain English, so remember we always start with pseudocode to think about how these things are going to work. We're starting off with a side length equals 60. So we're going to set our side length to 60. We're going to make 25 of these squares. So for a total of 25 repeats, we're going to draw a square using what the current side length value is, the number value for it. So when we draw our first square, side length will be 60. So it's going to draw a 60 square, all right? Then we're going to increase the side length by 10, not by 20, but just by 10, and do another repeat of this loop. And it'll just keep doing this over and over, increasing by 10, making a bigger square. And we should end up with 25 squares when we finish because we're doing 25 repeats, all right? So to set that up in the code, you need to modify the code that you just had. And how that pseudocode translates into Python is side length equals 60. Now I've already got for I in range 4 to draw our circles. So we actually have to use the next letter in the alphabet for this particular loop, which is J. So we say for J in range 25, that's setting up to do 25 repeats. We want to draw a square using our current side length. And this statement here, side length equals side length plus 10, that's just going to bump up or increase the side length by 10 units. So on the next repeat, it won't be 60, it will have added 10 on and be 70. So it'll draw a square that's 70 big, then it's going to add on 10, which will be 80. So when it does the next repeat, it'll draw a square that's 80. Okay, and it'll keep going for 25 times. So we should have 25 squares when we finish. Okay, so this is called incrementing inside a loop, and this is a new thing in this lesson, but this is done a lot in programming, okay? This is a way of automating, and that's what programming is all about, automating things so that we don't have to have hundreds of lines of step-by-step code. We can make a lot of the steps repeat and even build intelligence into them that they know each step that needs to get plus 10 bigger, all right? So this is called incrementing inside a loop. All right, so how the fully finished program code should now look, because we've done a few things there, it might be confusing. We've still got all that setup stuff there. And we're putting our pen down and we've still got our draw square with the side length, and that's all the same. But what we're doing down here is instead of doing a whole bunch, let's do 60, let's do 70, let's do 80, let's do 90, we're using this J loop. So down in the bottom here, rather than passing it step by step, all the different values going up in tens, we're going to make it manufacture the different values starting from 60. All right, so the first little square that's been drawn here is size 60 on its sides, but down in our loop, side length will get 10 bigger and be 70, okay? So the next time it repeats, it's going to go off and draw the square, but it's going to pass at 70. So this little next square here is a 70 square. Then it's going to add on 10 and do an 80 square. Then it'll add on another 10 and do a 90 square until it's done all 25 squares. So this is kind of the new part in here where we've got kind of built intelligence where we're telling it make each square 10 units bigger than the previous one, all right? So just take your program, you're keeping all the top part the same, but the bottom part's changing, so it looks like this, and put it in and run it. And if you want to, try 50 repeats and try side length 5, although I think the squares might get a little bit crammed up tight, but you can see what that does anyway. Right, and do that, and then that's the squares program finished and looking fully professional. Alrighty, so let's get into program 2, which is called Tilting Squares Madness. This sounds interesting. All right, so that many squares program, which was just finished, just do a file save as and save it as a new name, okay? Because we're going to make lesson 2, Tilting Squares Spiral Effect, okay? So now we can just speed our turtle up. Let's just speed it up so we got speed 0, max speed on it. We're using the same colors and everything. Now we want to get the turtle positioned up the top of the screen to start this one, all right? So when we do our pen up, we're going to be moving different amounts. So you'll have to change all this code that you had in between pen up and pen down. So we want to go forward 40, left 90, then we want to go right up 120, and then we want to turn the turtle right so it's facing 90, all right? So we've got to get the turtle positioned up near the top of the screen first up. And then we're going to have our same old little subroutine there that was just drawing a square with whatever side length we told it to draw the square with. And we're going to keep passing bigger and bigger values, but we're not going to do 25 this time. We're going to do more. We're going to have for j in range 68. And the side length, we're not going to increase it by 10. We're going to increase it by 5 with each loop. So we've got a +5 in there this time. And this is a new line of code. This is a magic line of code that's going to make it all happen. That after we finish drawing one of our squares, we just tilt the turtle right a little bit so that the next square is a little bit crooked compared with the previous one, and then it'll draw that square, and then we got that turtle right forward, so the next square will just be a little bit more crooked compared with the previous one, and that will actually make a spiral effect. So you're taking that previous program and not making many changes to it at all you're doing is changing where the turtle is positioned and changing your 25 to 68. Side length now is +5 instead of +10. You're adding a new line in, turtle right forward, just to give it a bit of tilting, and we're going to hide the turtle at the end when we're finished. All right, and what'll happen is you should be able to get this spectacular kind of mesh sort of spiral 3D thing happening here, which is actually made out of squares. See in the middle, it did start with a square here, and then the next one was tilted right a bit. The next one got tilted right. You can see in these lines, but then you kind of lose track in the 3D, that they were gradually tilting right, and that makes a spiral. So this is this fabulous 3D meshing effect spiral, and that's what we're going to get into in this lesson, doing a bit of tilting so that we can make spirals and not just have like a symmetrical square shape like we did with the kind of squares tunnel in program 1. So that's program 2 finished, so make sure you save that and it's working properly. Get the downloads if you're having difficulties, then you can check your code line by line against the one in the download, and that'll all be good. Okay, so challenge task 1, rather than tilting squares, have a go at tilting triangles, all right? You'll have to change the pen up start position so it's down in here, and it starts with a equilateral sort of symmetrical triangle in the middle there. Now remember, a triangle repeats 3 times and turns 120 degrees. So where it's doing that draw square, you'll have to change that to draw triangle and change it to 3 repeats and in your I loop and 120 degrees instead of 90, and that should get triangles happening. And that's this challenge task, which will make a slightly different spiral. It actually kind of looks better than the squares one did. And we just used a different color there. We used magenta. So that's challenge task 1. Try that one out. We've got challenge task 2 is the hexagon spiral. So we're not going to show you what it looks like, but you can play around with that and get that one. And then we're doing challenge task 3, the tilting circle spiral. All right, and that should come out like this, making this kind of tube of circles. Okay, so if you're having extreme difficulties with those challenges, for this lesson we have actually put together some solutions, some full code solutions for the challenge tasks. Your teacher might have them and give them to you after you've had a go at them yourself. Don't just cheat. There's no point in cheating and just monkey copying and pasting. I mean, we can put 10 cents into a photocopy machine and do that for copying. I mean, that's not an intelligent human thing to do. And we're trying to become intelligent human Python programmers, so make sure you have a go at them yourselves. All right, so you might want to pause the video, even check the timeline index, finish up at this section and come back and do the other part another time. All right, now we're going to make even more spectacular spirals, and there's a little trick to doing this. We're not actually drawing a square here. We're just drawing one line to start off with, but instead of turning 90 degrees, we're going to turn 91 degrees, which kind of gives crooked circles that we're also tilting. And with crooked squares, sorry, the thing looks circular in a spiral when you finish, but we're going to kind of get these crooked squares that actually have 91 degrees in them. So this is a little bit different, and that's what the finished output, that's 300 repeats, that's 400 repeats. So you want to have your turtle at speed 0 while it's doing this, because these are big drawings and they take a while to finish, but they look really good. You really get this spiral effect happening just by making your geometric shapes a little bit crooked. So the shape's going crooked while it's tilting, and that exaggerates the spiral and makes it even better. All right, so the program code needs to be carefully typed in to Python. So This is the program code. That's all pretty much the same, just setting up the screen. But we're not using a for next loop. We're not using for I in range 300. We're going to use a while loop. Now, a while loop's a little bit different. You have to have a repeats count for it. With a for next loop, it automatically counts what loop number it's on and knows where it's up to. But with a while loop, you have to manually do the counting in the program. So we need some program code to do the counting. It's not automatic for the program to know which repeat it is up to at any particular point in time. And we're going to keep moving the turtle forward. How we're going to make it grow bigger is use 50 plus the repeats count for the current repeat. And we're going to turn it not 90, but turn it 91, which will give it more exaggeration, give us a spiral. And we're going to have to add 1 to the repeats count. So just to explain that a bit better, the steps when you do a while loop, okay, rather than using a for I in range loop, and you need to learn both because you'll see both in programs when you go searching on the internet for programs or looking at other people's programs, you're working somewhere and they want you to modify a program, you'll see while loops are there. And they're also in other programming languages like VB.NET, JavaScript, C++, they all have while loops. So it's something generic that is in all programming, so you need to learn it. So we start off with the repeats count is 1. We're going to be doing our first repeat. And while that repeats counter is less than 300, we're going to keep doing all this stuff that's been indented, pushed in with the tab key. Okay, so it's going to do this 300 times because we've used less than 300 here. All right, and we're just moving it forward 50 plus repeats count, turning it a little bit more than 90 to exaggerate it. And then we have to keep track of the repeats count. So every time we've just done a repeat, we need to go repeats count equals repeats count plus 1. All right, then it's going to go up here. Repeats count, well, if we were on 1, it'd now be up to 2, which is well less than 300, so it'll do it the second time. Then repeats count 2 plus a 1 will be repeat number 3. That's less than 300, so it'll keep going until it gets up to repeat 300, and then it's going to see, oh, this isn't true, and it'll stop, and it'll just go down to this line at the end. All right, so you need to carefully do that. Make sure this code here is indented with your tab key and run that. Okay, and when you run that code, you should get this one, the 300 repeats. If you want to make it 400, put a 400 instead of 300 to get a bigger spiral, that's okay. But anyway, get that program in. That's the tilting lines one. And we're going to be making variations of this now for the rest of this lesson. All right, so the rest of this lesson, we're nearly there. Challenge task 4, you should only have to change one line of code in that previous program to make it do a triangle spiral instead of a squares, all right? And you want to turn it slightly more than 120 degrees. So what you have to do is see how we're turning right 91 here. If you put a triangle's 120 for turning right. Make it a little bit bigger, just make it 121. You can try 122 and see what it looks like, but try 121 and see what happens, all right? And the octagons, well, an octagon's normally 45, so you're probably gonna change it to, 45 plus 1 is 46. Now with this, to make a really compact, dense thing that's gonna actually look like a kind of cane woven basket when you're finished, change the turtle forward, so it does turtle forward 5 plus the repeats count times 0.25. So it'll do the growing a lot slower, okay? Because we're just saying take the repeats count and take 0.25 of it. So change your turtle forward statement so it looks like this. The star sign means multiply, so it's going to multiply your repeats count by 0.25, and that's going to make it a really squashed up, compact kind of shape, all right? So we'll leave you to try those two challenge tasks. So pause the video and try that. That's all done by just modifying that tilting line squares one, which we've already done. And the final challenge tasks, number 6, is to make this hexagons flower, all right? Now, we didn't make this one ourselves, or it does kind of look like a salad bowl or a basket maybe, but flower, whatever you like to call it. You need to go to this website. So if you go to that website, instructables.com, just get that link, paste it into Google and go there. That's going to have the code in there, but it does the code slightly different. Instead of doing forward, turtle forward 200, it just does FD 200. It uses these little shortcuts, right turn, turtle right, turtle.right becomes RT, and pen up and pen down can just be up and down like this, because they use this from turtle input star at the start. So we usually just do turtle import, right? But if you do from turtle import star to import everything that's in the Tkinter package, that'll also import these shortcuts you can use. All right, so you might like to use that in program. So we're just showing you that here, and you can go there and get the example code. Should just be a copy and pasted in job. We did change our pen color to magenta to make a pink flower. And after you got that one working, the final challenge task 7, is to make a hexagon flower with fill. So remember when we did fill in lesson 1 and we learned how to fill in colors? Okay, and you can see here I've still got some squiggles, which I'll have to fix up. Haven't done a review. What haven't we done? We didn't do a check document. Let's check for spelling here. Okay, so we've got to add all these guys to the dictionary because we don't want them showing up. And that's going to look a lot better. A bit careless there. All right, so we've got speed 0 underneath that. Instead of having pen color white or pen color magenta, make sure your pen color is white. So that should be double quotes there. I'm not sure if that's a double quote or not. It looks like a single quote, doesn't it? I see what it's doing. Because it bought it from a different... Because it bought it from the code editor, it shows up different in this editor. Okay, so anyway, pen color is white, fill color is red. Okay, so we're going to go to white outline, red fill. So set your fill color, before you start the loop for drawing, do a begin fill, and then after the loop, right at the bottom of the program, just above that exit on click, that's where you do the end fill. And then you should get this kind of nice, I don't know, red camellia flower or carnation flower or something like that with a bit of white patterns in it. Just makes it a bit interesting having some fill in there. And you could go back to some of those other spirals we made and do some filling in them as well, okay? So that would be challenge task number 7, and that would be the lesson done. Without making this too long and talking for too long, you need to make sure that you have done this and you keep that program and know how to do it, because we're going to be turning this into a multicolored spiral in later lessons. So you need to have that program done. You need to have this tube done, the circles tube, because we're going to be turning that into a multicolored spiral program as well, rather than just being one color like this in later lessons. And I think we're also going to work on a couple of these. So look, it's important that you have these programs done because you need these in later lessons. In later lessons, we're going to do file save as, make a new version, and finally we'll make a really cool rainbow version of this, which looks absolutely beautiful. That'll be in the last lesson we're doing, which is about 3 lessons from now. Okay, so remember our Python programming course that we showed you earlier is on PassyWorldOfICT.com Python. So that's where you go to see what lessons you need to do in what order. And that's where you go and click to get the download resources for the lessons as well. And have fun programming with Python. I hope you're enjoying making these shapes. I love this kind of graphics in Python, but I'm kind of a photography, graphics designer guy anyway, so I like this sort of thing. Hopefully you're finding this an enjoyable way to learn about loops. So we've learned a lot of stuff. We've learned for loops, we've learned while loops. This lesson we also learned the brand new functions. We're learning some really powerful programming concepts, but we're just translating it into doing drawings instead of kind of boring output console code, which I think is a much better way of doing it. So because it is so good, give it a thumbs up, because I'm sure you found this video was totally awesome. And make sure you subscribe to our channel so that you can find out when the next, gotta do it, totally awesome Python lesson is, because that way you'll get the regular video updates, and we will see you in that next lesson.